Welcome to Electronic Ed YouTube channel. Today I will show you how to design and simulate a frequency divider using Verilog. We will also simulate the design using tools like Icarus verilog or iVerilog and GTKWave. So let's start by creating a folder named PWM. Next, open the folder, right click and select Open in Terminal. Now we will create a file using gedit. Type gedit pwm.v and press enter to open the gedit text editor. Since we are writing Verilog code, the .v extension is necessary. Let's write the Verilog code for the PWM module. Once done, press Ctrl S to save the file, then close the text editor. We now have our Verilog module. To test its functionality, we need to create a test bench. To do this, type gedit pwm underscore tb.v and press enter. Now let's write Verilog test bench code for the PWM module. Once the test bench is written, save the file. Next, let's check for syntax errors in both the module and test bench. In the terminal, type the command iverilog space pwm.v and press enter. If no errors are returned, your code is syntactically correct. Now, to compile both the module and test bench together, use the command iverilog followed by module name pwm.v and test bench file name pwm_tb.v and press enter. If there are no errors, an executable file named a.out will be generated. To render the VCD file, the VCD file is used for viewing waveforms. To run it, type vvp a.out. A VCD file named test_pwm.vcd will be created. Since we didn't use $finish in our test bench, the simulation will run continuously. To stop the simulation, press Ctrl Z to stop it. Now, with the VCD file generated, we can view the waveforms using the GTKWave tool. To do that, type the command GTKWave space test_pwm.vcd and press enter. GTKWave will open. To see the waveforms, expand the hierarchy by clicking the plus symbol next to PWM_TB. Then expand DUT. To view the signal list, right-click any signal, select Append and confirm by clicking Yes. Finally, zoom out to properly view all the waveforms. This concludes the tutorial. Please subscribe to channel and stay tuned for more tutorials on chip design using open source tools. If you have any questions, feel free to comment below and I will do my best to answer them.